Eric Darling here with Darling Data. Haven't recorded in a few days here just because I've been very busy with stuff in my GitHub repo, but I was scheduled out far enough that I didn't have to worry about it too much. I'm very excited because the pins that I had made of my Department of Database Optimization logo thing, they're very hard to see here, but I assure you they're glorious. Came in, and these will be coming with me to all of the live appearances that I attend this year, as long as I don't run out, because who knows how popular they'll be. Never can tell with these things, can you? Anyway, in today's video, we're going to be talking about dealing with parameter sensitivity in stored procedures. This is not going to be a full explanation of like the thing that leads up to parameter sensitivity, which is parameter sniffing, because parameter sniffing, I feel like that's a fairly easy thing to find out more about. And I really just want to get to sort of the meat of how to deal with problems that arise from parameter sniffing. Now, parameter sniffing isn't always a problem. Parameter sniffing is happening all the time and is generally a good thing. Where it starts to hurt you is when your data is skewed. Like you have some data that has lots of values and some data that has very few values. And that's when you start dealing with plans that, when they have to process a lot of data, maybe aren't good for that job, and vice versa, right? You can even run into like big, like hefty parallel plans with lots of hash joins that aren't good for processing a small amount of data. So that's what we're gonna talk about today, you and I. If you like this channel so much, if you are just enraptured, whatever the right word is, by this content, and you want to support this channel with monies, you can sign up for a membership, link down in the video description below. If you don't have money for whatever reason, or you just don't like me all that much, and you want to make Bats sad, you can like, you can comment, you can subscribe. That will make Bats vaguely happy. If you want to ask me questions very privately that I will answer very publicly on my office hours episodes, that is the link to do so right there. Right, that's the one. This link is also the video description. Go figure. And I don't. Oh, apparently I can click on that link. Great. All right. Awesome. Anyway, oh man, never gets old. If you would like some help with SQL Server, because perhaps asking questions or watching videos is just not cutting it, and you need to really dig in and start figuring stuff out. I am a consultant, and I am available to consult on all of these things. If you need a health check, a performance analysis, if you need hands-on server tuning at the workload, query, index, whatever level, help responding to performance emergencies, or developer training so that you don't have performance emergencies anymore. Well, in the words of that funny guy, that's me. Ah, hmm. If you would like to get some very high quality, very low cost SQL Server training, you can also get that from That's Me. Again, this link fully assembled for you down in the video description. You get it for about $150 US and 0 cents, and that lasts for the rest of your life. You don't need to subscribe to that, but you can if you want, I guess. If you want to see me live and in person, I will definitely be at SQL Saturday, New York City 2025. There is a performance tuning pre-con by Andreas Volter on May the 9th. That is the Friday prior. That is a full day event. I highly suggest you sign up for that. Pass on Tour will be taking place all around the world. New York City, August 18th to 20th. Dallas, September 15th to 17th. And Amsterdam, October 1st to 3rd. And of course, there is the Grand Poobah Past Data Community Summit, which will be in Seattle, November 17th to 21st. So all excellent events that you should put your butt in a seat for. If you don't, they won't happen anymore. Then what will we do? Well, just have to go use Databricks. But with that out of the way, let's talk about this whole parameter sensitivity thing. Now, one of my favorite parts of the job is, of course, being vaguely pedantic and people saying, we have a parameter sniffing problem. And I'm like, no, you don't. You have a parameter sensitivity problem. Because, again, parameter sniffing happens all the time, right? Normally, procedures, they run a lot. They cache a plan, they reuse the plan, everything's fine. And I'm not saying this is a perfect situation, right? Like Postgres is the precise opposite, where like I know that there are some things you can do like at the connection level to reuse plans, like connection pooling or something, but like for like most of the time you have all these little queries that might come in and do one thing, and where you get plan reuse from SQL Server, you don't get that from Postgres, and you compile a new plan every time. Perhaps somewhere in the middle there's like a good middle ground, but what I'll say in favor of SQL Server here is that like the cache, like with Postgres, like you can't really control the caching behavior. With SQL Server, you do have a lot more control over the plan caching behavior, right? Like by default, plans are going to come in, they're going to compile, they're going to get cached, they're going to get reused. But with SQL Server, you have a lot more tools at your disposal to deal with like problems that arise from that. Now, granted, like a lot of people use third-party applications that were written by idiots, and they don't have that kind of control. But that's where Microsoft is kind of come in and add features like the parameter sensitive plan optimization that like tries to help with that. We're going to talk about that more in a minute though. But it's not the worst idea in the world what SQL Server does. It's just, you can hit some issues with it. Now, what you do have to be mindful of is how data is currently distributed and how it ends up getting distributed over time, right? Because like you might start off with a very small amount of data that has a fairly uniform like distribution, and parameter sensitivity is just not going to like hurt you in those situations, right? And that's why like the optimize for unknown or like setting a parameter equal to a local variable, that might work fine for small, fair, like uniformly distributed data. But if you have highly skewed data, that what happens with local variables and optimize for unknown is not what you want, because it's like, well, we're just going to assume that everything has this one estimate, and screw it, right? Like there's very few situations that actually works well in. So, sometimes you have to go out of your, like you have to like really get involved and do some crazy stuff to deal with parameter sniffing. A lot of the times though, like parameter sniffing has a fairly like narrow set of root causes. Like you might have like a lot of single key column indexes, and SQL Server might be able to like use one to partially find stuff, but it needs like either to do a like look in another index, another non-clustered index on your table to find more data, or even go like do a lookup back to your clustered index or heap to find additional data, filter additional predicates. Like there's just all sorts of stuff that like having wider multi-key with include indexes or covering indexes can solve a lot of parameter sensitivity issues, right? Getting key lookups out of plans, that's like one of the most common causes of parameter sensitivity problems. You can like also like making sure that your queries are not written in ways that like make it so that using indexes efficiently is difficult, right? Like writing sargable predicates, stuff like that. Not like wrapping your columns in is null is probably the most common like problem that you see with these things. So like there's a lot of stuff that you can do that can cut down on parameter sensitivity issues that don't involve the kind of stuff I'm going to show you. But there's just a lot of examples of the other stuff, and I like showing you the kind of more intricate stuff. Another thing that you can do quite frequently is use temporary objects to isolate critical parts of a query and to materialize manageable chunks. Now, for those of you out there who are confused, this is not a good use for common table expressions, because common table expressions are not materialized in SQL Server, at least not as of this recording. There's no way to do it. But like taking care of a lot of the most basic, like fix your query plan stuff can cut down on a lot of parameter sensitivity problems. You don't need to go directly to this stuff that I'm going to show you. You do need to get like an example of the small plan and an example of the big plan, or like the parameter values that crisscross in there, and then like compare the plans and just see like, oh, like what happened in this one that was a disaster when it was shared with this one. So I recorded a video quite a while back. Well, not quite a while. It was far enough back, but I was still wearing glasses, so it was before, but it was pre-LASIK. It was in the PL days, where oops, that's not the right line. It's the URL, dummy. Called Defeating Parameter Sniffing with Dynamic SQL. This will be in the video description if you want to go see that. But yeah, SQL Server has 2022 has a feature that's supposed to help with parameter sensitivity, but it has some problems. Like basically the stuff in here, right? So it only works with a quality predicate. So like if your parameter sensitivity issue is with like a greater than, less than, greater than, equal to, less than, equal to, with like a date range, it's the most common one in there, it's not going to help you with that. So it's only a quality predicate. It's only one of your equality predicates, right? It's not like there are multiple ones that SQL Server will be like, oh, you're sensitive, you're sensitive, you're sensitive. It only chooses one of them. And you only get 3 bucketed query plans based on that. The problem is that this is entirely heuristic. Like there's no query hint to say, hey, SQL Server, this query is real sensitive. It's got big feelings. You might want to help this one out a little bit. It like there's just like you just can't do that. So there are certainly times where it has been, will be, can be effective, but it doesn't kick in for all of them. So just to make sure that we are all properly set up for this, let's make sure that all of this stuff is in there. And now you might be able to tell from these delicate little red squiggles that I have already created these indexes, so these are already in place. So we've already like I've pre-checked a few of the boxes here. Like we have good indexes in place, our query is written well, like a lot of the stuff that like would normally be like the first things I look at when I'm trying to figure out where this parameter sensitivity problem is coming from. Like I've checked those boxes. And since I'm on SQL Server 2022 and I've got my database in compat level 160, like we're all set up here, query store is on, and the parameter sensitive plan optimization is enabled here. So this is the store procedure that we're going to be looking at. It's my favorite parameter sniffing example because it is so, like the data, like there's one parameter in here, right? And it's on this for the vote type ID column in the votes table. And this data is so crazily skewed, but this thing never actually kicks in, right? Just never actually works and does something. So like if we look at the data in the votes table, like you're just going to see like this incredibly wide spread of values, right? We have from 37 million, then the 33 point something millions, and a 2 million and a 1.2 million, and then this whole thing down in here where there's, you know, there's hundreds of thousands, and then down in here where there's in just like the tens of thousands and low thousands and hundreds. It's like this is very, very skewed data, but the parameter sensitive plan optimization doesn't kick in for this procedure. Like for some reason, the only time it kicks in is when I accidentally update the table and have one more row in there, and it's really annoying. But that's my demo failure. That's not anyone else's fault. So if we run this for vote type ID 4, we get this very narrow, very exploratory, navigational, little loopy, sorty, key lookupy thing. And this thing asks for a fairly small amount of memory, right? It's the 130 megs. Now, if you'll recall, for vote type ID 4, there were only like 733 rows, so SQL Server came up with an execution plan for 733 rows that made total sense. The problem becomes when we go and try to run this for vote type ID 1, which had 3.7 something million rows in it, it runs for a considerably longer time. This is one way you can sort of tell that the parameter sensitive plan optimization isn't quite kicking in, right? It's like we still don't have a result, and it's been 15 seconds, and it'll probably end up being around 20 or so seconds before we actually get a result back. But yeah, so we do this, and things aren't so hot in here. Now, I will give SQL Server some credit, and you know that doesn't happen. Oh, I mean, it happens a lot more often than people give me credit for. But we do spend like 20 seconds in this spill, right? Minus like a second or so over here. But there is a long time spent in this spill. Now, where SQL Server does do okay is if we run this again for vote type ID 1, another intelligent query processing feature will kick in called memory grant feedback. And this runs in about half the time now, but we still have a fairly sizable spill here, right? You can still see that we spend a bunch of time. So we went from like 20 seconds down to like 7 seconds, which is good. The problem sort of is that like if we juggle executions where like the small plan executes a whole bunch of times and then we try to execute a bigger plan again, it all just falls apart. Now, if you recall, vote type ID 2 has 37 million rows, which means I can't even run this during this video and like show it to you. I had to run this beforehand. We spend a full minute and 34 seconds. Well, I mean, minus, 11 seconds over here or whatever, but like a full like minute and 20 something seconds, like just spilling in the sort, right? This sort spills a whole ton. It's not a good time, right? We got to spill level 8. The one thread that we have for this query spills all over the place and things aren't good. So like you do get some reprieve with enough features that kick in, but a lot of this stuff does rely on higher compat levels, and a lot of people just haven't gotten there yet for various reasons. So, there's just like, if you're stuck, you're stuck, right? There's nothing you can really do there. But like coming back to our list of things that we can do to sort of fix stuff. Our indexes cover everything that we care about. Right, we have includes that cover like the remainder of the query, right? Like our key columns take care of our where clauses and joins and whatever, and our included columns cover our select list stuff. Our queries are also written in a way that's not awful, right? Like they're all sargable. I'm not doing like any weird isnull, coalesce, substring, left, right, nullif stuff in there, so that's fine. But what on earth are you doing? Excuse me. So what we're going to look at next is just using a temporary object to get the critical part of the code into a temp table and reduce parameter sniffing for this, right? So we're going to create a store procedure down here called vote sniffing temp. And what we're going to do is create a table called votes, and then we're going to insert stuff into the votes table for the vote type, where the vote type ID parameter is concerned, right? So that's like the real big difference with this batch of code here. And then we're going to select out of the temp table, and we're going to do our little not exists to the other stuff. And what I want to show you for these is that, like, if we just juggle between 4 and 1, this will be a good enough execution plan for these. Right, like we do this stuff, everything's generally okay, right? Like this takes a second for 4, it takes about a second for 1. Nothing in here is flying off the rails awful, right? We run this in reverse for 1 and then 4. We still get like about like one or so second of execution time. Nothing in here is like stuff that I'm going to be super concerned about under most circumstances. We still have a problem with vote type ID 2 though. Right. So if I were to run this for vote type ID 2, we would end up. Oh, sorry. This is the query plan that we want. If I were to run this for vote type ID 2, we would spend a full 10 seconds shuffling. Well, I mean, we seek to 37 million rows, and then we aggregate that down to some number of rows, and then we only end up putting 1 row in there, but the whole thing just takes a shellacking, right? It's like, boof, beats this thing up. The second query, like that selects from the temp table, is still fine, but this one up here is not so great. So we still have a problem to solve for when this query executes, and like when we split it into a temp table, it's great for everything except vote type ID 2. Vote type ID 2 still needs special handling. So we're gonna do like kind of a hybrid approach here between when we go to the temp table and when we just run the procedure, right? Because if if you were to run the main procedure for just vote type ID 2 and let it compile with that, it's okay, right? It's like pretty good for the amount of data it needs to deal with. So let's create or alter this thing, which is just going to be basically the original query that we had with no temp table involved. And then we're going to take advantage of our temp table procedure here. And then we're going to have a wrapper procedure. And we're going to tell SQL Server, is it a vote type ID 2 vote type ID equals 2, we're going to go right to this one. And if vote type ID is not equal to 2, then we're going to go into the temp table version, right? Because we don't want all those rows moving around the temp table. We don't want to deal with that 10-second query. It's not a good time. So let's just make sure that this actually created. Forget if I did that or not. Don't want to hit any errors here. 20 minutes in. So now we have our vote sniffing outer procedure, and if we run this for vote type ID 401, we're gonna hit the temp table version of this, and everything is going to be generally okay with it, right? Like nothing awful is happening in here. And then if we run this for vote type ID equals 2, we're just going to hit the plain query for this. Now, granted, like there are likely things that we could do in here that might speed this up, but this whole thing when we get the plan just specifically for vote type ID 2, finishes in about 4 seconds, and quite frankly, for the amount of data that it has to deal with, that isn't awful, right? Like, could it be better? Yeah, sure, probably. But like, just just to get this from taking a minute and a half or 10 plus seconds down to taking 4 seconds for these, and like just a couple of seconds, like even just like running those other ones combined, it was like a second and a half total. It's not a bad outcome. Now, this all does come back to, like, there are more things that you could do to leverage other solutions, right? Like we looked at the temp table and sort of like splitting up the temp table and the real procedure. But there are, like I said earlier, I recorded a video a while back about how, all the really cool things you can do with dynamic SQL in order to make this stuff like run even faster. So one thing that I will do sometimes is something that looks kind of like this, where depending on like if the vote type ID comes from this is like the 3.7 million to million-ish number of rows, we'll tack 1 equals select 1 on here. If vote type ID equals 2, then we'll tack 2 equals select 2 on here. And then if vote type ID is in one of the small ones, we'll do, well, I think that was supposed to be 3 equals select 3, but I did 4 equals select 4. I don't know. I guess it all turns out the same. But just what this guarantees is that we'll get 3 different plans based on the size of the data that we need to deal with. This is a lot like what SQL Server tries to do automatically, but doesn't do automatically for all of your queries. Again, there are a lot of heuristics involved that go into whether that kicks in or not. So, like, if you have to take matters into your own hands and you want 3 separate plans for things, this is one way of doing it. Another thing that you can do is, like, you can use dynamic SQL to add in different hints based on the values that come in, right? So this is one of my favorite things in the world to do, where you it's almost like making a plan guide for SQL Server without all the fragility that comes along with plan guides and like forcing plans in Query Store that work for a little while and then stop working suddenly, and there's not really a good explanation why. You can really tell the optimizer what to do based on different scenarios. So again, going with like the sort of high number of stuff, you can say, I want a loop join for you, and if I vote type ID equals 2, then I want a hash join for you. And then if you're one of these, you can do option hash join with a recompile hint. There's all sorts of things you can do to like tell the optimizer, like, hey, treat these things differently. Like, I want a specific plan for these, and you're not getting there, so this is what I want you to do. There are also things that you can do to optimize for specific distributions. Now, remember, the thing with optimize for hints is you are not optimizing for a value, right? I mean, you are, but what you're really optimizing for is a number of rows that match that value, right? Like it's like this, like it's the cardinality estimation that you're optimizing for. It's not just like you optimize for 1. Hey, that's great. Now everything thinks it's vote type ID 1. The optimize for hint is there to like for cardinality estimation purposes. So like for these, because vote type ID 1 has like the most rows in it for this group of values. Oops. Why is Zoom it working against me so heavy today? Because vote type ID has the most number of rows for this set of values, we optimize for vote type ID equals 1. vote type ID equals 2 is just terribly lonely on its own. And then for this group of vote type IDs, 15 has the most rows. So we're optimizing for vote type ID equals 15. This is like a pretty fair way of managing that. If you really just want separate plans for everything, you can tokenize your dynamic SQL, and you can say where vote type ID equals like this thing with this swirly bracket vote type ID. And then in your SQL statement, you can replace that token with the vote type ID value that gets passed in at runtime, which for the vote type ID column where there's only like 16 total like values you could have in there, if like having 16 plans for this, not the end of the world. If this thing had like lots and lots of different values, I would probably want to bucketize it more. But with just this many values, I'm totally like only like 16 things. I'm totally comfortable just having 16 plans for things, because parameter sensitivity is such a nasty witch to deal with that like sometimes you have to make these trade-offs, right? You're going to sacrifice some plan cache space to not deal with like your server tipping over because, you know, a weird plan ended up in the cache on you. So these are some like interesting and somewhat intricate ways that you can deal with parameter sensitivity. But again, you know, a lot of this stuff does come down to, you know, just making sure that like there's nothing else just pathologically wrong with the indexes, the way the query is written, you know, like making sure that you're not doing anything goofy in there with like local variables or table variables and stuff like that. You know, you know, things that would mess up cardinality estimation and make it sort of feel like parameter sniffing when you're getting like this wacky estimate that doesn't look anywhere near reality for the number of rows you're actually dealing with, and you're like, it's parameter sniffing, but no, it's this other thing. So there are definitely things that you should start with in your queries before you go to the crazy train approach. But if you need to go to the crazy train approach, these are the things that I most commonly do. So anyway, parameter sensitivity, not fun to deal with, but there are lots of clever and interesting ways that you can deal with it. You know, again, start small. Make sure that, you know, your query and your indexes are properly aligned. Make sure your query is written in a way to take advantage of your indexes. Make sure you're not using anything that screws up cardinality estimation on its own, like local variables, table variables, non-sargable predicates, you know, scalar UDFs in your where clause or something, like all the stuff that contributes to really bad plans without, like, you know, they can make it look or feel like parameter sniffing when it's not, or parameter sensitivity when it's not. But if you've already done all that stuff, these are very cool and interesting ways that you can fix that. Optimizing for specific values, like using query hints, including recompile on some things, bucketizing the dynamic SQL so that you get a different plan for different like batches of groups of values in your skewed data. All sorts of neat things you can do. So anyway, whew, this is a long one. I did a lot more talking than I thought I would. Anyway, thank you for watching. I hope you enjoyed yourselves. I hope you learned something. And I'll see you in the next video about store procedures, which according to the numerics up here will be about dynamic searches. So since we're talking about store procedures, we gotta talk about those, because I still see people mess those up all hither and yon. Well, anyway, that's enough for this one. Thank you for watching, and I'll see you next time, my friends. Mon ami.